So in this question we need to prove by induction. So what we will start with is when n equals 1. So when n equals 1, then we can say that the left hand side, which is this side, this is the left hand side, okay? The left hand side would obviously be 1 over 1 times 3, and that equals 1 over 3. And right hand side is equal to, so this is the right hand side, is equal to n is 1, so 1 over 2 plus 1, that is equal to 1 over 3. So left hand side equals right hand side, hence statement holds true. So we can do only one more, that is when n equals 2, then you would have left hand side equals 1 over 1 times 3 plus 1 over 3 times 5, and that equals 1 over 3 plus 1 over 15, and that is 15. 5 plus 1, that is 6 over 15, that is 3 times 2 is 6, 3 times 5, 2 over 5. And the right hand side would be equal to n is 2, so 2 over 2 times 2 plus 1, that is 2 over 5. So once again, left hand side equals right hand side, hence statement holds true. Okay, so hence statement holds true. Okay, so now let me say that suppose statement is true for some n, for n equals some value, some integer k. So n equals k. So k is a positive integer, right? So suppose statement is true for n equals k. So then we need to prove that the statement is true for n equals k plus 1. We need to prove that the statement is true for n equals k plus 1. So if we can do that, that means the proof holds. So if n equals k, when n equals k, we can write, you see, 1 over 1 times 3 plus 1 over 3 times 5 plus, instead of n, we write k. So 1 over 2k minus 1 multiplied by 2k plus 1 is equal to k over 2k plus 1, because the statement holds true for n equals k. So now we need to prove when n equals k plus 1. So if n equals k plus 1, then what happens? The left hand side is equal to 1 over 1 times 3 plus 1 over 3 times 5 plus, so this, we write this term 2k minus 1 multiplied by 2k plus 1 plus, there's another term, isn't it? This is the kth term, k plus 1. What would be the next term? The next term would be 2k minus 1. So you have to add 2 to it. So 2k minus 1 plus 2 multiplied by 2k plus 1 plus 2. So then we can write the left hand side as equal to 1 over 1 times 3 plus 1 over 3 times 5 plus 1 over 2k minus 1 times 2k plus 1 and plus 1 over 2k plus 1 times 2k plus 3. Okay, so multiplication. So this is our left hand side for n equals k plus 1. Now we have to prove this is equal to LHS is equal to RHS. So RHS is equal to, instead of k, we are going to write k plus 1. So it would be k plus 1 over 2 times k plus 1 plus 1, that is 2k plus 3. This is what we need to prove. So how do we do that? So we need to work around the left hand side and make it equal to the right hand side. So we can say that continuing from here, you know that left hand side is equal to, we can say this entire thing we already know is equal to k over 2k plus 1. So I can write that is equal to k over 2k plus 1 plus 1 over 2k plus 1 times 2k plus 3. So then this equals, the denominator is going to be 2k plus 1 times 2k plus 3, and the numerator will be k times 2k plus 3 plus 1. So that is equal to 2k square plus 3k plus 1 over 2k plus 1 times 2k plus 3. Now if we look at this now, so the denominator is 2k plus 3 and we already have a 2k plus 3 in the denominator. We need to make the numerator equal to k plus 1, and this k plus 1, this needs to disappear. So that's what we have to work, we have to do. That we will do with some algebraic manipulation. So then 2k plus 1 equals 3, okay? So then I can write this as the numerator as 2k square plus 2k plus k. The 3k I break it down as 2k plus k plus 1 over 2k plus 1 times 2k plus 3. So that is equal to, I can now take 2k outside the bracket. It would be k plus 1 times k plus 1 over 2k plus 1 times 2k plus 3. And you see, then we can write this as equal to k plus 1. If I take it common outside, it will be 2k plus 1 over 2k plus 1 times 2k plus 3. And you see, then 2k plus 1 can be cancelled, and I'm left with k plus 1 over 2k plus 3, which is equal to the right hand side. Okay, so that's equal to the right hand side. And if we replace k with n, replacing k with n, so then we get n plus 1 over 2n plus 3. So that's proved for n plus 1th term. Yes, that's done then.